Hello, this is Retro Marky. Long time no make video. You can blame this COVID for that. But on a positive note, I have a little bit of time to do some electronics and computer tinkering. So you probably remember from one of my videos previously that I made a clock module here based on the Ben Eater series on YouTube. I've now actually completed the clock, so it's now on two breadboards here, and it's got some more advanced features, shall we say. So the basic difference is now on auto mode here, you can actually ignore that LED. This is really the clock output here, and as you can see it's running in auto at the moment. I've got my potentiometer so I can change the clock speed here. But what we can do, which is nice, is press this switch, and as you can see the clock is now stopped, and by pressing this button here we can pulse it manually. So that's the main updates to this, and also some debouncing circuits to make sure the switch can't be held down or anything like that, so it does consistent pulses there. So pop that back on. Now the other thing I've done is connect it to a program counter which I built recently, and ignore the Arduinos for now. This Arduino is not really doing anything at all, it's just there in case I wanted to power the module separately. So we've got a program counter here. I don't know how clearly you can see on the camera, but this is actually a binary counter counting up from 0. And that's connected to this clock here for the time being. Now what we can do with that is, one thing we can do is, there's a lot of wires here. So we've got a clock out enable here, and that basically is repeating the program counter, and that can go out to a bus if we want it to. Pop that back on. Also clock enable, so the clock can actually be stopped like that. So that's just pulling it to the negative rail. Pop that back on to there. And another thing I mentioned was before was this manual switch, and so what we can do also is, now as you can see here, 1, 2, 3, 4, 5, 6, 7, 8, etc. So we can also go through the program counter one instruction at a time. Now obviously this is nowhere near a finished project, this is just the initial start to a 8-bit computer. So in summary, we've got clock here which runs a monostable and astable, with some extra circuitry over here now, giving us some auto manual control, and now that clock is running a program counter which I need to pop it back on. So that's now running a program counter here. On the right here I've also wired up a Z80, but I think I'll leave that for another video. On the left here I've got my 6502. What I've done is, firstly I'm using this clock which I'm running nice and slowly, so you can see the program counter counting up very slowly, which is the way I want to do things because it helps me in the learning process. And another thing I've done is connect a logic analyzer, so we'll have a look at that, and we can actually see this represented digitally to understand a little bit more about what's going on. So I'll cut to that now. Cut. Okay, so this is the result on my PC from the logic analyzer. We've got our 8 bits here, 0 to 7, and then using a parallel configuration we can actually read what the CPU is doing here. I don't know how clear it is, maybe I can zoom in a bit. So as you can, hopefully you probably can't see that well, but here we've got 7A, 7B, 7D, 7C, 7D, 7E, 7F. So that's just the counter counting up from 0. If we just run it a second, then you can see that in action. I actually find this quite fascinating. So at the moment I'm on CF, D0, D1, D2, D3, D4, and that's exactly what's going on here. So these outputs are going to the LEDs from the address. So the address bus is going to the LEDs to give us a visual representation through LEDs, and then also going through a logic analyzer, and that's the result of that. So hopefully that was interesting. The main point for me was getting the program counter done. Not sure what I'm going to do next. There's obviously quite a few other modules. It needs a data bus, it's going to need RAM, it's going to need some kind of ALU and a bunch of other stuff. There was one more thing, which is here, and this is another little project I've done, which is a tiny basic computer, and that hooks up the composite to a monitor, so I'll show you that one day. I don't want to overwhelm too much in this video. And also, yeah, I think I'll do a quick video at some point explaining the Z80 that I've wired up. What I have done is actually make this, unlike the 6502, which is going via my clock here, this is an independent unit, so it's actually running by itself, and the Z80 does need its own clock. So I might do another video to update you on that, and maybe we can look at find out what the frequencies are on these different devices. I think this is running about 300 kilohertz, so it's fairly slow. If it goes too slow, the Z80 won't run, whereas the 6502 will actually run almost anything at all. Okay, well, I hope that was interesting, and thanks for watching. Retromarky out.